Let's take a look at our piecewise functions. Remember that this worksheet is organized in steps. This graph would be the step 1, step 2, step 3, and then we're going to put them all together. You notice these are the exact same graphs, all together as one piecewise function at the bottom. Then we'll answer the questions below according to this piecewise function, this piece right here. Okay, let's take a close look at the first one. This is a line, so we need to figure out the y equals mx plus b, or more specifically, the m and the b. Okay, my slope and my y-intercept. First, let's take a look at slope. Slope is rise over run, so if I start at a point, say this point that they're given, I would go up 2 and over 1 to get to the next point. You can see that that pattern continues up 2 over 1, and that's the slope of this line. So since I went up 2 and then left 1, my slope is actually going to be negative 2 altogether. My b then is my y-intercept. This guy doesn't currently have a y-intercept. It doesn't cross the y-axis. But let's continue this slope to see where the y-intercept would be if he did cross the y-axis. So starting at, say, this point here, it looks like I need to go over 1, down 2, and then I could go over 1, down 2, and get to here. I'm still not at the y-axis yet, so I'll go over 2, down 1, and then over 1, down 2, there we go, the correct slope, and then I'd be right here. So this point would technically be my y-intercept, which is -8 if you count that out. So my b is -8. Let's put this all together now. My y is going to equal my slope of -2, so y equals mx plus my b is -8. Now, the problem with leaving our answer like that is this graph, if I left this equation, would represent this graph if it had arrows on it and it went on and on forever. However, this graph is only covering a certain portion of the entire picture. If I look closer, my graph is only really covering the portions between this x value and this x value. So this is the only portion of my graph, right? So let's look at the x values, or the domain of this graph. I'm basically going from the farthest most left point, which would be x equals -5, -5, and it's going in between, so the picture is all in between x is -5 and x is -2. My entire picture can fit in between x is -5 and x is -2. Does that make sense? I'm just looking at my domain, so the width of this graph. It's all of this entire picture can fit in between my leftmost point of -5 and my rightmost point of -2. So the way I'm going to signify that in my answer box here is I'm going to say, okay, this is the equation of the graph if my x is in between that -5 and that -2. Last but not least, before I leave this answer as is, I want to take a look at what kind of dots I have going on over here. Remember that an open dot is represented by a less than or greater than sign, whereas a closed dot is represented by a less than and equal to or a greater than or equal to sign. So that means when I have my answer over on the left-hand side, I need to have a less than sign and then a less than or equal to sign for the part that's less than or equal to -2. I just need to add this underline here to signify that, hey, there was a closed dot in the -2 part, and there was an open dot in the -5 part. So here's my -5, open dot, here's my -2 x value, closed dot. So I underlined that one. For the next piece, let's go ahead and find the y equals mx plus b. My m here is 0, and my b is easy to see, 1, 2, 3, 4, 5, 6. So that means my overall equation is y equals my m, which is 0x, plus b, which is 6. If you wanted to simplify this, you could really just write y equals 6 here, because 0x, of course, just zeroes out and goes away. Then I need to write my domain restriction. Honestly, I always start my domain restriction like this. And then I know I'm going to fill in these numbers here, and I might underline one or both of these pieces. So let's look at the graph and see where our x has to be in between. Again, if I look at the leftmost point's x value and the rightmost point x value, my graph is in between -2 over here and +3 over here. So my entire graph can fit in between those two numbers. Also, I see that my -2 version is open, so I'm going to have a sign like this, whereas my 3 version is closed, so I'm going to have a sign with an underline underneath. So now I can just go ahead and add those numbers in. -2, 3, we said the 3 part was closed, so I'm going to put a underline underneath that less than sign. Last but not least, we have this one. Y equals mx plus b, so our m here is 1. You can see that up 1 over 1 action going on here. And my b, if I was to continue this line, I would be going all the way here. You can kind of see that slope happening. So my b is 0. Therefore, I could write this equation as y equals m, which is 1, x plus b, which is 0. You can leave your answer like this, or if you'd like to simplify it, it's really just y equals x. Of course, this graph is not going the entire distance of the entire page or going on for infinity, so we need to put a domain restriction here. So the domain restriction, again, always starts like this, and then you just need to find your leftmost point and your rightmost point. The leftmost point, the leftmost x value comes from here, which is x is positive 1, 2, 3, and the rightmost value comes from here, which is x is 5, 6, 7. X is 7. So my graph basically exists between the points 3 and 7. It looks like this one is going to be an open value, this one is going to be closed or underlined. So I'm going to put that 3 and the 7 in, and I know my 7 needs to be underlined because it had a solid dot. So now that we found the 3 individual pieces, we're going to put this all together for our final answer. Again, you can see that this graph came from up here and we already have the equation for it. This piece of the piecewise function came from here. We already have the equation for it. And finally, this piece we already have the equation for. So to find the equation for the entire piecewise function all put together, our answer is actually going to have 3 pieces to it. And I'm going to say y equals, and then I have the entire worksheet basically put on one big spot. So y could equal from the top -2x minus 8 if that x was in between -5 and -2. Or it could equal 6 from the middle one if that x is in between -2 and 3, or it could equal x if that x is in between 3 and 7. So again, the way I filled this out was I literally just stole them from up above. In other words, the equation for this graph is this if my x is in this portion of the picture. The equation for the graph is 6 if the graph is in this portion of the picture. And the equation for the graph is this if the graph is in this portion of the picture between 3 and 7. All right? Now that we have that done, we can go ahead and attack these 6 problems on the bottom. Remember, your f of x notation is usually written like this. The entirety f of x is equal to y. Remember, f of x is the same thing as y. So basically these questions, I'm giving you an x value and I want you to tell me the y value. So the number inside the parenthesis, it really represents your x value. So on here, go to x is 1 on your graph, which is right here. And then I basically need to see where is my graph located. How high or low, what is my y value if my x is 1? If I go up, I see my y value is up 6. In other words, I had to travel up 6 to hit my graph at x equals 1. Here is x equals -3, so I'll go to -3, and then I'll travel down until I hit my graph at y is -2. In other words, this coordinate point is -3, -2. I gave you this piece. I'm asking you, what is that piece? Okay. The next one, I'm looking for f of 6. So I'm going to go over 6, 1, 2, 3, 4, 5, 6, and then I'm going to go up until I find my graph. So over 6, 1, 2, 3, 4, 5, 6, I'm right here. If I go up 2, 3, 4, 5, 6, I hit the graph right here, and so my y value was 6. I had to go up 6 to find my graph. Let's look at number 4, f of 3. So finding 3 on our x-axis puts me here, okay? Now I have to travel up until I hit my graph. The thing is if I travel up 3 spots, I get to right here. Again, I'm at x equals 3, I go up and I get to here. This hole, this open dot, represents that this line does not have a value at this point. This graph right here gets very, 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 very close to this point, but it does not have a value. That's why we use the symbol like this as opposed to like this. This is less than or equal to, in other words, it equals that dot if I'm using a closed circle. It is less than, it doesn't equal that dot. There is no value in this dot. That's why it's open. So please don't tell me that the answer to number 4 is positive 3, because there is no value there. You would travel right through there and go all the way up to here. So if I'm at x equals 3, I would go all the way up. Here is a closed dot, so that is a value. So 6 would be my answer to number 4. Number 5, f of x equals 0, f of 0 equals something. So let's go ahead and plug in 0 for my x, go up until we find our graph, and we have to go up to 6. The very last one here is kind of asking the opposite or the inverse of the original problems. Now I'm giving you your y value. Check it out here. Remember this notation. F of x equals y. So this entire thing equals your y value. Your y value here is 4. I'm basically asking, what does your x value have to be if your y is 4? So on this one and this one alone, we're going to start on the y-axis at 4. So I'm on my y-axis traveling up or down. I need to go up 4 and then figure out where my graph is at. If I'm on my y-axis up 4, if I go over, I can find my graph is at 1, 2, 3, 4, right here. This is the point I'm talking about. So if I went up 4, I had to go to the right 4 to get to my graph. All right. This next one is another piecewise function that I've split into sections for you. So I have step 1, step 2, and step 3. We'll put it all together to get the entire piecewise function down here, and then we'll answer some questions about it. Let's take a look at the first one. This is a line, so I just need my m and my b. It looks like here that my slope, if I start from, say, this point and go to, say, this point, be careful here, I need to go up 1, 2, 3, 4, 5, and over 1, 2, 3. So I think my slope is actually up 5 over 3. If I use that slope to continue the line to find the y-intercept, I'm, say, here, and I go up 1, 2, 3, 4, 5, and then over 3, which would put me right here at a y-intercept of 11. Be careful if you count this, it's actually 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my b is 11 in this case. I'm ready to write my equation then. Before I do, let's write the domain restriction so we can put it all at once. Okay, so let's talk about how far right and how far left our equation goes. It looks like it starts with a closed circle, so the x is going to be like this, and I have a closed circle on the left, and my leftmost point is negative 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. And my rightmost point, which was an open circle, so I'll leave it ununderlined, is at negative 1, 2, 3, negative 3. So again, my graph is between these two spots. That covers the entire domain between negative 9 and negative 3. Now I have all the information I need, so I'm just going to scoot over here and write my answer in this little box over here. My graph is y equals my m, which is 5/3, x plus my b, which is 11, if my x is in between negative 9 and negative 3 with the negative 9 inequality underlined. For the next one, let's do the same thing. Let's start with just my m and my b and my domain restrictions, and then we will write it all out on the other side. It looks like here my m is 0. Remember, when you have a horizontal line, you have an m of 0. Here it looks like my b is negative 1, 2, 3, 4, 5, negative 5. And my domain restrictions, it looks like my graph has a closed circle at negative 1, 2, 3. My domain is going to be like this. X is in between, looks like -3 with a closed circle, so I'm going to underline it. And then it is to the furthest right, it is 2, and since this circle is not closed, I'm going to leave this guy not underlined. So my graph is between -3 and +2. We're ready to put this all together into our answer. Our answer then is going to be y equals my m, which is 0, x plus my b, which is 5, if my graph is in between -3 and 2. Of course, the -3 part is underlined. If you want, you can write this equation as just y equals -5. Of course, you don't really need that 0x piece in there because it just zeroes out. All right, here's our first parabola. We have a little half of a parabola going on. This is your vertex point of the half of the parabola. You can kind of imagine the other half going up over here. To graph parabolas in my class, you need to decide if this is opening up or down and what the vertex is. Then we'll do our little domain restriction and we'll have all the notes we need to be able to write this equation. Let's see, this guy definitely opens up. So that means the A in my equation is going to be positive. My vertex here is this point, which I think is +2, -4. Yep, +2, -4. And then my domain restriction, it looks like this guy has an open circle at x equals 2, and it has a closed circle at x equals 5. So this graph is in between 2 and 5 with the 5 guy underlined because he is closed circle. So now I can plug this all in. Let's remind ourselves that this is a parabola, so it's going to follow the form y equals a times x minus h squared plus k, where these guys are my vertex. Of course, I switch the sign on the x guy. And then the a really just is either in my class going to be positive or negative, deciding if this guy opens up or down. So we're ready to write our equation. My y equals, my a is a +1, so I can just leave it as, I don't even have to write it in there. You could write a plus sign or a +1 if you want, but you don't really need to. Okay, so I'm gonna go straight to my parenthesis here, x, and here's the deal, I gotta switch the sign on this. So instead of writing +2, I'm gonna write -2, quantity squared. And then on the back for my k, I leave this k alone. I only switch the sign on the h, leave the k alone, so I'm gonna leave it as -4. There's my equation. And then I just need my domain values, my domain restrictions, which we already took care of. It's between 2 and 5 with the 5 underlined. If x is between 2 and 5 with the 5 underlined. All right. And now we're ready to put it all together. So I'm just going to steal the equations that we already worked on. I know that y is going to equal 3 different pieces. From the top, it equals 5/3 x plus 11 if that x is in between -9 and 3. I know, or sorry, -3. And then from the middle, y is equal basically to -5 if my x is in between -3 and 2. And from the last one, y is equal to the quantity x minus 2 squared minus 4 if that x is in between 2 and 5. Okay, so again, I just found these by stealing all of the stuff above. I already put the y equals on the outside, so I just actually put the equation, no y equals. And there you have it. You have the graph of all 3 of those pieces put together in a piecewise function. Let's go ahead and answer these questions at the bottom. I have for number 7, my x value is -9. So on my x-axis, let's go out to -9. Which is right here. If I go down to find my graph, I have to go down 1, 2, 3, 4, so that would be -4 to find my graph at this spot. For number 8, I'm going to plug in -6, so I'm going to go -6 on the x-axis, which is right here. I have to go up in this case to find my graph at x equals 1. Or I'm sorry, the y value is 1. For number 9, I'm looking for g of 0, so I'm going to plug in 0 into the x-axis. In other words, I'm not going left or right. So how far down do I have to go to find my graph? I have to go down 1, 2, 3, 4, 5. So my y value, if x is 0, my y value is 5. For number 10, I'm looking to see if my x is 2, what is my y value? So let's go to the x is 2 right here. And now where is there a y value? If I look down here, do I have a y value? It looks like I have a spot here and a spot here, but both of them are open circles, so neither one of these are actual values. So I claim that there isn't an answer to this. There are no values on this line, y equals 2. So I'm going to put no solution. There is no solution on the line at x equals 2. If I look at x equals 2 over 2, and then I look down this line, this value right here, this open dot, is not a value. This is not a point. And same with this. This is an open dot, so it's not a point. You go right through there. There is no graph on this value of x equals 2. Let's try x equals 4 instead. If I go over 4, I'm right here. The graph is already right there, so that means I don't have to go anywhere, so it's at 0. And last but not least, I'm changing things up. I'm giving you the y, I'm asking you the x. So if y is 0, let's go, we are not going up or down, we're right here. How far do I have to move left or right to find my graph? If you notice, I gave you 2 spots because there are 2 different answers. I could either go left or I could go right to find my graph. Here I could go left 1, 2, 3, 4, 5, 6.5. So negative 6.5. Or I could go to the right 1, 2, 3, 4. Again, this one is asking you, okay, you have the y value of 0, what is your x? So if I'm on my graph, I'm at 0. How far do I have to move left? I want to find my x, so how far do I have to move left or right to find my graph? Since there are 2 spots where this graph crosses the x-axis, you have 2 answers for number 12. All right, last but not least, we're going to go ahead and tackle this one without breaking it into step by step. We can go straight to the answer of this. Okay, so I'm already gonna write my y equals, and I'm gonna do my big bracket thing. I'm so bad at drawing those brackets. Oh, that was a lot better. Think about it. There are going to be 1, 2, 3, 4 pieces to this equation. So make sure you give yourself enough room. There's going to be 4 equations and 4 domain restrictions. Also, 2 of those equations are going to be lines and 2 of them are going to be parabolas. All right, let's attack this piece by piece and maybe we can do it all at once. Let's talk about this first one. This is going to be a line, so I need my M, my B, and my domain restrictions. My M here, it looks like it's up 1 over 1. So I would say my M is 1. My B, if I continued that up 1 over 1 fashion, I would cross the y-axis all the way up here at B is 2. Now my domain restrictions for that is, it looks like my leftmost point here is at x equals negative 1, 2, 3, 4, 5, 6, 7, 8, negative 8. And so my x is between negative 8 with a closed-in circle, so an underlined value there, and it's also in between my rightmost point with an open circle is negative 1, 2, 3, 4, 5 right there, so negative 5. All right, so that's that for the first part, this blue line here. Let's go ahead and attack the parabola, and we'll do that one in red. So this next parabola here we'll do in red. It looks like this guy opens up, and his vertex is at negative 1, 2, 3, negative 3, comma, negative 1, 2, 3, 4, 5, 6, 7, 8, negative 8. All right, and his domain restrictions are x is in between, it looks like negative 5 and 0. Again, I found those because I am looking at the leftmost point, the x value of the leftmost point, and the x value of the rightmost point. And it looks like this one is underlined, so I'm going to, filled in, so I'm going to underline the inequality next to the negative 5. All right, next, let's go ahead and do that other line. I'll do that other line in purple. And I'm just going to kind of sweep it out here and do my work out here. It looks like this guy has a slope of 0 and a b, or a y-intercept, of 1, 2, 3, 4, 5, 6, up 6. And finally, my domain restrictions are that it is in between 0, and 1, 2, 3, 4, 5. It looks like my 0 needs to be underlined because I have a closed-in circle. This one is open, so not underlined. Okay, last but not least, in green, we will do the last parabola, and we'll kind of stick it all the way over here. It looks like this guy opens down, so we need to make sure our A is going to be negative. And my vertex here is over 1, 2, 3, 4, 5, 6, 7. So 7, comma, and it's up 1, 2, 3, 4, 5. 7, comma 5. My domain for this is X is in between. It starts here, which is 1, 2, 3, 4, 5. X is 5. And it goes all the way out to 6, 7, 8, 9, 10. It looks like this one is a closed circle, so I'll make this one underlined, whereas this one is an open circle, so I'll leave that not underlined. Okay, that was a lot of work, but we're ready to go ahead and put it all together in one big answer. Let's start with this. Y equals mx plus b. So y equals, we already wrote, we're just going to write the m, which is 1x, plus our b, which is 2. And then I'm going to write my domain restriction that I wrote in blue there, -8, is less than or equal to x, which is less than -5. Perfect. Now let's move to the red one. Right here, this is a parabola, so I'm going to use my parabola or my quadratic vertex form. I notice that it opens up, so it's going to be positive, so I can just go straight to the parenthesis. X, I switch the sign, so +3, I leave the sign, -8, and then that's good to go, and I just need my domain restriction. X is greater than or equal to -5, but also less than 0. Now I'm ready for my purple. Y equals mx plus b. So y equals m, which is 0x, plus b, which is 6. And that is if my x is in between 0 and 5. Just copying down that purple domain restriction there. And last but not least, the green one, the green parabola. This is a parabola, so make sure it's squared. Ooh, this guy also opens down, so I need to make sure I have a negative sign outside of my parenthesis. And then I'm going to do x. Opposite sign of 7 is -7, and then I leave the sign on the 5, +5. If, and then here it is, my domain restriction, x is in between 5 and 10. There it is, all of them all put together, and we did it all without having to necessarily graph or write the equations of all 4 of those individually. Okay, let's take a look at these questions here. The first one says, okay, what do we get if we plug in -4 for x? So let's zoom in here and take a look at when x is -4. So I'm on my x-axis, I go left 4, and then I need to go down, it looks like, to find my graph. It looks like I need to go down 1, 2, 3, 4, 5, 6, 7. So my answer is going to be -7 there for my y value. All right, number 14 looks like we need to plug in -3 for my x value, so I'm going to go left 3, and then it looks like I need to go down to find my graph, so I'll go down 1, 2, 3, 4, 5, 6, 7, 8. So my answer for number 14 is -8. For number 15, I'm plugging in 2 for my x value, so if I go over 2, then how far do I have to go up to find my graph? 1, 2, 3, 4, 5, 6. So my answer for number 15, when I plug in 2, I get 6. For number 16, when I plug in 5 for my x value, I'm going over 5 in the x direction, which means I just need to go up 1 in the y direction, and I found my graph. And then for number 17, if I go -8 in the x direction, 1, 2, 3, 4, 5, 6, 7, 8, I have to go down 1, 2, 3, 4, 5, 6 to find my graph at -6. All right, last one is number 18. If you remember that we write this one differently, because here I gave you the y value, you have to find the x value. So here I am with the y value of 4. So let's go on the y-axis to 4. 1, 2, 3, 4. Now it looks like I need to travel positive over here to find my x value. But look, I see that it crosses this line of y equals 4 twice. So I'm going to have 2 answers for this. Either at positive 1, 2, 3, 4, 5, 6, or 8. So my answer to this one is 6 or 8.